This is Architect Like a Pro for performance for availability of your Microsoft Azure virtual machines. My name is Rick Claus, and I am going to be your host for the next, 75 minutes or so. If I can find my clicker to be able to say, let's advance that. If you have not seen me before, I've been here at the last 3 or 4 different Tech Eds / Ignites for the last little while. I've spent the last 2 and change years working with the Azure Compute team, and I'm going to be sharing with you some of my knowledge of working with a variety of different sized customers with what I call the oops factor of architectural design, where you have architectural design going on, usually in the back of a cocktail party napkin, and they come up with some ideas. They look at how they're going to go and move their on-premises solution over to an Azure world, or maybe design something brand new, net new, and they realize it's not quite performing the way that it should, and then they hopefully call someone in, and they call someone in, and they call 2 friends, and so on, and then eventually it comes down to someone that can come in and take a look at it. So this is some of the experiences that I've had over the last little while. I thought I'd share them with you. If you want to get a hold of me and converse, if you want to, you're more than welcome. My email address is up there on the screen, rclaus@microsoft.com. Likewise as well, you can catch me on the Twitters, @RicksterCDN. I tweeted out, just as a little bit of a note for everybody that's here, I have enough stickers, if you want one, of this. Can you get that there? There we go. My other computer is an Azure Data Center sticker, prime for all the laptops. Also, you can put them on the bumper stickers of your Utes and impress your friends if you want to. See, I know what a Ute is. That's impressive. So yeah, come on down. I'll have those out at the end of the day to be able to do that. If you're interested in going to that party tonight, the buses start picking up at 6:45 or 18:45, I do believe. We'll have plenty of time to wrap up this and take your questions. And you can also ask me Azure questions while we're on the roller coasters together. Don't quote my answers, but you never know. It might be more interesting to see how it comes out. Just look for me. I still wear the hat, and the hat does not come off even on roller coasters unless the guides tell me to take it off, and then you won't recognize me because I won't have my hat on. So how about this? Who here works with IT projects? Everybody raise your hand because you're all in IT. Maybe you're developers, maybe you're infrastructure folks, maybe you're responsible for infrastructure. Good, we're on the right place. But this is the thing that I like now. I sat around, I was speaking at a conference in Las Vegas. There was a room of speakers that were there in what's known as the speaker room, and I was chatting with these dev guys, and these dev guys are like crack, massive brain kind of folks that go off and do these massive projects and stuff like that. And I'm like, so, how do you find developing in this new world of cloud environments different than developing on premises? Hushed silence. Yeah, little murmurs here and there. Talking about some of the newer capabilities like the app fabric or the service fabric, the different types of buses you can use to be able to queue your messages up and that sort of stuff. And those are definitely kind of some very interesting tools you can use. But essentially, you're writing an app. It's going to be consuming compute resources. That's going to be then going and querying and talking to the local disk of an operating system. Either you manage it, in which case it's an IaaS box, or we manage it as an infrastructure provider that gives you a platform as a service, and we're supposed to go through and make sure that's going to be optimized and fast to be able to work, and then you kind of work that kind of stuff out. But ultimately, it's kind of the same basic concept for the lowest level of how things work, lowest level architecture. So they've come down and I've said, well, so what kind of stuff do you hear? And so one of them says, well, I usually hear just make it work. Net new project, here's my idea, cocktail party napkin, go ahead and do the design. I'm going to have front end, going to have back end, going to be talking to databases, doing machine learning, all sorts of big fancy stuff, and using all the latest and greatest. They have a finite amount of time to get it completed, a very finite amount of time and resources to be able to complete it, and they need to be able to hit those dates regardless if they're doing kind of an agile, if they're doing some kind of a scrum stand-up, if they're doing some kind of a waterfall or a lean, you choose whatever it is. Just make it work by the delivery. Ship it, done, finished. Phenomenal, great. Then maybe, if there's problems with it, they go back and they revisit it again to simply make it right and fix it so that it's all working, it's all fine, and then it's done. It's shipped, it's delivered, millions of people are using it, it's all fantastic. Generally, they then come in at the third level of kind of things and then say, it's running really slow, just make it fast. You already made it work, you already made it right, so it's all correctly and working, there's no bugs on it, but now it's just not performing the way that it should be. What do you think is the most common way that any infrastructure person is going to go in and make something faster? Come on, it's not that late. Throw more resources at it. Bump it up. Chuck more CPU, chuck more RAM, speed up those hard disks, do whatever you want. It's your fabric on your own infrastructure. What do you do in a cloud environment? Lots of options, we'll talk about them. The trick is this make it fast part, make get better performance, only if it's not fast enough. Who determines if it's fast enough? The end user determines if it's fast enough. If they find it's too slow, or if you're losing sales, or if someone's leaving your platform to go to a different platform, to a different competitor to get their stuff because it just works better or works faster, that's when it comes into play. Now, one person came back with some very interesting things. He says, actually, Rick, there's a couple of things that came up besides these basic ones, which is, ship, move on, done, go on the next thing, that come up now inside of a cloud environment. I'm actually being asked to make it secure. It's inside of a cloud environment. Maybe it's hosted on AWS, maybe it's on Azure, maybe it's on Google Compute, whatever it happens to be. They don't want to be front page news about the fact that something's now gone on because someone has gone in and, I don't know, used simple passwords on the root of the database for being able to access the data, or they've gotten some kind of a simple attack for password attack and they managed to get advanced level credentials or whatever it happens to be. But now, make it more secure comes into play. And then maybe even a newer one comes up. Make it more cost effective. If you're deploying that application on top of a public cloud, regardless of your provider, you're paying for those resources to make it better. I've got a funny story of a particular, I'm going to leave the company nameless, I'm going to leave the organizational nameless, and they were basically told by their infrastructure folks, their CIO folks, the office of the CIO, we need to move everything up or move this particular project up and start using the cloud. So you cannot use and provision and your request for new hardware of a new SAN, dedicated hypervisors and that sort of stuff, that's been denied. You have to go use the public cloud. And so they came back with a spec, they sat down with the architect, the project planner came back to the infrastructure folks and basically said, here you go, please provision me 12 G5 machines with 32 terabytes of SSD storage to get the maximum performance. You know how much one G5 costs to run 24 hours a day, 7 days a week? Non-discounted MSRP pricing? $6,556.23. Or, work out the math, 13 cents a minute to run. Multiply that by 12, and that's what they wanted to have to run their application. We gave them something smaller, and then we did some performance testing on it, and it came back that they could probably get away with a couple of D2s, which cost $242 a month for the performance level for what they're looking for. And this is something that I had a conversation with, I don't even know if he's here or not, just before this one session. It might have been Ian, I think his name was. He's a traditional infrastructure IT pro, and he's working with different customers that are now working inside of Azure environment. And it's like all those skills that you have for working in the IT industry for the last dozen or so years of racking and stacking servers, of designing applications, of building infrastructure, that sort of stuff, all still applies inside of the cloud environment. You just have to pivot it, make a little bit of a pivot to understand where it's at. I've only been involved in a couple of dozen projects in my career from a dev perspective as an infrastructure advisor to that dev group of people that were working with it, and even other infrastructure people too, that actually sat down and did analysis of disk I/O and understand what type of queries were more efficient on the databases and how to set those databases up on those drives to get the maximum performance. You potentially still need to go down to those kind of levels if you want to squeeze out the best investment of your resources. Don't discount the fact, I would love it if you guys would go and provision yourself 12 G5s. Especially if it was on my quota, but I don't have a quota, because that's great consumption. But ultimately, I'm going to do the right thing, and I'm going to do a more proactive approach to analyzing what your resources requirements are, and making sure that things run correctly, they run fast, they're performant, and also they come out being secure, and they also are cost effective for you, since you're going to go off and continue to do this. Generally speaking, when you have those kind of conversations with your infrastructure teams, with your developer teams, and you start asking about IOPS, this is the kind of expression that I see an awful lot. So I thought I would start off with a little bit of an introduction, a little bit of storytelling for the stuff that I've seen, and then kind of break it down. If you've seen my infrastructure discussion yesterday morning-ish, where I said what's new for Azure IaaS for server huggers, some of the slides are a little bit duplicate to be able to share because some of the things are the same. I go into a lot more detail into limits, bandwidth, capabilities, configurations, and stuff like that in this session here. But starting right off the bat, I'm also only going to be talking and zeroing in on stuff that I know about, which is core infrastructure and compute. I'm not going to be talking about web services, app services, or service fabric, because that's stuff that I don't know that much about other than how they work conceptually and where you want to use them. This is for taking your existing apps or taking apps that you want to take over to an Azure environment. It's going to be running top of an Azure IaaS stack, or anybody's IaaS stack, to tell you the truth. So you have to, first of all, start off by meeting the family. And the brief history around the family basically is that we've been running infrastructure in some way, shape, or form, either as a underlaying layer for our PaaS solution, Platform as a Service, with architecture. In the data centers that we run, regardless of their size, you basically have your compute stamps, and then you also have your storage stamps. And then our fabric is spread across those, and you combine the network, the storage, and the compute together to make up your different VMs. We classify or group these together in things that are called families. Starting off with the A-class family, that's what I call your budget highest value family. Those are going to be entry-level Intels and AMD boxes that are relatively cost-effective to run if you want to run them 24/7. Do you need to run, actually that's the question I came up with first, is do you need to run your workloads 24/7 inside of a cloud environment? It's rhetorical, you don't necessarily have to answer, but you can if you want to. No, you don't. If your application's architected to not need to be up and running or scaled down if it's not required. The cloud necessarily isn't going to be the cheapest solution. This is the Microsoft guy telling you this. The cloud isn't necessarily going to be the cheapest solution if you do a one-for-one, what's here, move it up into there, and then leave it running 24/7. Because you're paying for it, just like you're paying for it down here. A big chunk of your savings can come from spinning things down, spinning things up just in time, scaling them up as required, scaling them down as required, scaling them out as required, scaling them in as required. That dynamic, elastic capability of what the cloud brings, your apps have to have that understanding of how that works. You can't necessarily go and take your SQL database and all of a sudden scale it out across 16 servers and then back in again across one server. It doesn't work that way. At least that last time I checked and talked to my SQL friends. So A-series is what's there. That's fast, it's quick. Technically, what I use this guy for is my proof of concepts, how it's working, do I know what I'm doing to be able to build the basics and then be able to have people go off and use this. I still turn these things on and off, and I can even automate the turning of them on and off to go off and save some resources. They range anywhere from an A1 all the way up to an A7 or A8. When you get into an A9 and A10, that's when you start to get into high-value compute nodes that are designed specifically for large data crunching and data analytics. And then you got a 9 and a 10 also. They're the exact same thing as the 8 and the 9, but they don't have the super expensive high-speed network between them of RDMA networks. So that's basically your A-series family. And then you, again, pay for these by the minute based on the operating system that you're running. You also have a slight surcharge on top of that for the app/operating system that's on there. The D-series is the really cool, fun ones these days. They're the more modern infrastructure that's out there. They have an SSD on the blade itself that the hypervisor/fabric is running off of. We use that SSD for caching, which gives you better performance. You'll see more later on when I talk about how disk works and how caching works. The D-series are also more modern Intel processors, which typically run about 50% faster than the A-series machines were. These Ds go all the way from a 1 all the way up to a 14. And based on the number of cores that they have, they're able to attach more disks, which means you can get more disk performance and disk IOPS out of them. G-series came out after that, which is very, very cool. It's so awesome, we skipped over top of the E and the F and went right to G. G also happens to be the first letter of a particular sci-fi reptilian evil person that took over a particular country back in the 50s from a black and white film perspective, but we can't use that name because it's copyrighted. Anyway, that's the G that's out there. Gs are awesome. They are still, at this point in time, the absolute largest virtual machine you can get with the fastest storage inside of the public cloud based on how you slice and dice. Different vendors are going to say, well, ours have more cores. Yours don't have as many cores as we do. Our cores are not split up and hyper-threaded across them. Theirs are. You get less performance out of them, even though you have more of them. So it's a tit for tat. It's going to be a leapfrog continuously for which vendor has the next biggest and the next largest. So currently we're in the lead and we're enjoying that. That's the G series that's out there. And then premium storage was something that came out, which is absolutely awesome. That is SSD back storage, which gives you tons and tons of IOPS, which ultimately can end up being one of your biggest bottlenecks with cloud computing and with any kind of computing that's out there. We introduced the DV2 because the DV2 is just now rolling out. The DV2 is now available in a couple of data center regions. And in those different DV2s, they're the latest generation of Intel Haswell processors. Intel processors. They're 35% faster than the machines that were 50% faster than the A's. So you work out the math for how fast they really are. In case you didn't know, we actually decide where these different types of machines go based on the age of the data center region as well as customer demand. As more customer demand comes for these different types of compute power, then we make the appropriate purchases and planning and everything else like that to swap some old stuff out and take some new stuff back in again. And it's a continuous evolution. That's part of our $5 billion that we invest every single year as a minimum into our data center regions around the world. I think with the announcements that just came out in the last couple of weeks, we actually are now up to 28 different regions around the world as far as our data centers are concerned. That's just crazy. And then finally, we have the GPU-enabled one, the Ns. They're currently planned for. They're on a roadmap. So there are some private previews in place of people that are using them. These are NVIDIA-based CUDA accelerated GPUs. No idea in pricing, no idea in performance and spec at this point in time for what I'm aware and aware of them. The main thing is they're designed for compute intensive and also super high networking capabilities with RDMA as well. Lots of choices. More you use, the more you consume. You pay for any one of these with your operating system on it on a per minute basis when you go off and spin them up. One thing I will mention is something else that's in regards to the Ds and the Gs. They have a sister family, if you will, that has an S at the end of them. They cost the exact same as the non-version without the S. The only difference is those particular systems are placed inside of a data center in a region where premium storage is available. Therefore, they can attach and talk to the premium storage disks to be able to get more performance. So if you look at the difference between a DS and a D, essentially the same, except you'll see the IOPS are higher, bigger, greater, meaner, leaner. Now, cost-wise, I talked about how these things come with different types of costs that are involved. I like to talk about the G family because, again, I'm a hardware geek. I used to build systems and rack and stack servers in my old days. The G series, if you go and take a look at it, it's 32 cores, 448 gigs of RAM, 7 terabytes of local storage, and its latest generation Intel processors. 64 attached disks are now possible on this monster of a VM, G5. One word of caution, expensive to run for a long period of time. However, if you take a look at the actual math on this particular board up here, this is a while ago I did this, $66,000 to be able to buy an equivalent piece of hardware to rack and stack inside your own server environment. That's non-discounted prices. That's also not factored in the fact that you have to triple that cost of purchasing over the course of about 3 to 5 years to depreciate the value of that hardware. That's running 24/7, $180,000, completely estimated, that sort of stuff. You can fudge the numbers to make that out. The biggest thing is 11 to 15 days before it even arrives in your data center. I don't know if it takes longer. Does it take longer to ship stuff here in Australia? Everyone's kind of nodding. It's coming from Singapore. It depends, you know. Anyway, I could have probably had a G5 deployed in West US inside of my data center close to where I happen to be based out of Redmond, and it would have been already deployed, up and running. I could log on to it based on when I started talking about all these different families. And it's running. And I turn it off when I don't need it. I turn it back on again when I do. So, rather interesting to be aware that those different families come into play when it comes into performance. Just warming up my machine here to be able to show you something right quick. And this is number 7. I'll switch to in just a moment. I'll show you this guy here. He is 7. There you go. So this is a box that I have up and running currently in my West US data center. And just bare basic specs for this guy here. I call this guy disk attach. Under my local server, if I click on it, there we go. We see that it currently is a 7 gigabyte machine. It's got 144 gigs of local space available to it. And it's currently a Xeon 2660 2.2 gigahertz machine for what it looks like. It's running Windows Server. Nothing too crazy or fancy about that at this point in time. This guy, thank you very much, on my portal for disk attach, comes down here under sizes. He's currently set up to be a DS2. He has 2 cores, 7 gigs of RAM, 4 data disks possible, maximum IOPS of 6,400 IOPS, 14 gigabytes of local SSD, and it also happens to support premium storage. I hit the stop button and zoom too quickly. MSRP, absolutely non-discounted, $208.32 to run that guy 24/7 if I needed to. If I wanted to, I can also go in this particular data center. I can view all of my different systems that are possible. View all. And now I'll be able to see the DSs. Here's a DS14, more cores, more RAM, more disks equal more IOPS, and then I have a much larger price tag associated with it potentially. If I scroll down some more, in case you haven't seen this, here's my A's. Where is it? Here's an A2 standard. I don't think I'd personally run a server with only 3.5 gigs of RAM, but it's possible. He's only going to get possible 500 times 4 IOPS, so basically 2,000 IOPS, 133 bucks. And then keep on scrolling. DV2s are not currently available in this location, so they come out grayed. And here's my G5, not available as well in this particular location, but it would have been $7,179 for this particular configuration that I chose. So all these are available at deploy time when you choose to build your infrastructure. I happen to choose a very simple one that's only going to give me the ability to attach a couple of disks, and that's going to be one of the demos I'm going to be showing you in a little bit of time when I do some more deploys in just a little bit. You are able to go through and change your disk size, change your CPU size and your overall machine size if you want to, but it does require you to basically redeploy that machine over to a new blade, potentially, and therefore give you more access to more resources that are available on that individual compute stamp. Now, bottlenecks that come up generally come in play because you're using shared infrastructure, and we have to make that shared infrastructure available to all of our customers, regardless of who you happen to be, and we therefore have to put in these different governors in place. Just like you would have a governor in a car to keep you from going too fast, even though the engine can handle it, you basically are wired to only have certain capabilities so you don't affect other people inside of your hardware. And so here's some examples of what some service manager limits exist. And you've got some limits that happen at the subscription level. You've got some limits that happen inside different services and also between storage accounts and stuff like that. What I will mention here as an example is if you're using virtual machines, you've got up to 50 per old-fashioned cloud service at any given time. You've got 248 that can fit onto a virtual network. On a storage account, you can only have 100 per subscription. That can be possibly upped if you needed to with a service call. How many different blobs you can have per storage account. Important thing, while I'm not spending much time on this, is I've given you the URL to it, but ultimately, don't pay attention to this page, please. This is Service Manager. If you're deploying net new applications on the Azure environment, you shouldn't be looking at Service Manager or Classic as the way you do your deploys anymore. Always deployed using the latest and greatest Azure Resource Manager capable infrastructure using the new portal, using PowerShell, using Visual Studio plugins to talk to the cloud services, deployed to the Resource Manager. There's very few situations, I can probably count them on one hand, for why you would want to use Service Manager as opposed to Resource Manager. So, Azure Resource Manager. What exactly is it? Think of it as a basic V2 of the way that we go through and we deploy Azure resources and talk to different APIs within Azure to provision disks, provision CPU, provision networking capabilities. The idea is that you create a resource group, you choose that's now a new container, a new grouping of resource objects that can be locked down to certain people. They can be set up so that people can only view, people can go in and modify. You can break them up on a per project basis. You can break them up on a per technology basis. It really depends on how you want to manage your subscription. You can possibly have 12 different subscriptions if you wanted to. And have different owners of those different subscriptions, and then have sub-owners or admins at lower levels if you wanted to. But basically, think of it as a grouping. It also is where you're able to go and put in those things that I just talked about, which is called role-based access controls, where individual devs or individual infrastructure folks have to be able to authenticate, to be able to go and look at the Azure subscription. Based on who they authenticate the subscription with, they will be able to do more or less to that individual subscription. So picture this. You've got a new project. You now want to go off and do proper design. Do you make one resource group? Do you make a resource group for VMs, a different resource group for storage, a different resource group for network, a different resource group for front end, a different resource group for back end? The answer is it depends, however you want to carve it up. Last thing I'll mention about these is also the fact that you can go through with resource groups and also the resources within them and associate tags with those different resources, which allows you to bubble things up inside of your billing, which becomes very interesting for how that works. So with Resource Manager, the classic model of doing things, we used to use cloud services as the way you grouped your different VMs together. You could then go in and start and stop the cloud service, which would start and stop the VMs within it. You could then go and delete the cloud service, which would delete the VMs, usually. Example, inside the cloud service, you'd have a VM with an IP address associated with it. It would then go in and have the ability to go and talk to a storage account. The storage account would be where your VHD files were stored, and also your data disks were stored. You then also would go and talk to your virtual network over top of a subnet, and that's basically how it worked. That's not really the way that most people think of how they put together resources on an on-premises world, an on-premises environment, load balancer as well. With Resource Manager, or V2, the way that we do things, basically, we create the resource group, and then in parallel, we create all the different components we call on different resource providers within that resource group to make a storage account, to make a VM instance, to go in and make a NIC, to be able to go and make a VNet, whatever it happens to be. And it's defined within this template of a file that then gets processed by the resource manager to be able to go off and create the infrastructure you're looking for. You're able to go and put in these different dependencies within inside of that environment to say, you know what, you have to have the storage account before you actually make the VM, because the VM can't live unless it has a storage account to live inside of. You need to be able to go in and have the load balancer depend upon the NIC being initialized before it's able to go off and do anything. The VM can then go and reference that NIC, which then has the ability to talk to that load balancer. That NIC is then able to go off and talk to a public IP address, talk to a different VNet, a different subnet. We have all these different relationships that are now able to be made with references inside that environment. This basically allows us to go through and blow stuff out in parallel as opposed to sequential to very quickly provision new infrastructure and new hardware for you. New resources for you, sorry. And then obviously with network cards, stuff like that, we can also go in and deploy security groups, access control lists, and everything else along those lines. So this is the one you're going to want to look at when it comes down to doing some stuff. An example for Resource Manager, on a per region basis, you're able to deploy with a default subscription 20 compute cores for that one particular subscription in that one region. That can be raised with a simple support ticket to go up to 10,000 per region. It's just a little sanity check. We don't want you going all crazy with Resource Manager templates and blowing out a massive scale 2,000 CPU D4 all that 2,000 times as an example. So it's just a little soft safeguard that we have for you. No reason why we can't open that up if you want to. You can have as many different co-administrators as you want, so long as they're within your directory that you have set up. You have storage accounts that are available on a per region basis as well that you can use. You've got resource groups that you have. You've got objects inside those resource groups that are available as well. You've got so many different Resource Manager reads and writes that make changes to your environment so fast or so slow based on what those different levels are. And then also things like availability sets, which we'll talk about in just a little bit. Instead of only having 50 inside of a cloud service, we now have 100 inside of an availability set that's coming up here. The one thing I will call your attention to is the one at the very bottom. I keep on going back to this IOPS discussion. It is really a discussion around IOPS. How many IOs, input outputs, do I have to worry about throughput to my data disks to be able to get performance, usually on a machine. Disk is going to be one of your slowest things you have to worry about. 20,000 IOPS for a single storage account that's out there. This is where I take a pause, look down below for a bottle of water, and see if anyone has any questions so far. If you've ever been to one of my sessions, you know why I'm doing this pause for a question. And oh, we have one taker. Yes, sir, up there on the side. Great question. I'll repeat it for the recording and also for the room. If I go off and make a very big machine or a small machine or any kind of machine at all, I spin it up, the operating system initializes, I log on, I do some stuff, I work on it for 27 minutes. It's all done and configured. I then go and I shut it down. I then spin it up again 2 months later. What's the charge involved for that particular machine? You're going to be paid for, based on the disk, you're going to be paid for the amount of bits that are written to the disk and are at rest for the storage, not for the empty space, provided you're talking spinning disks. And you're only going to be billed for the number of minutes that the machine was up and running, provided when you shut it down, you didn't go into the operating system and say, shut down machine. Instead, you did it programmatically, either with an API call, with a PowerShell command, or with the portal to say, shut this machine down, or stop machine. Because what happens is, we take that machine, when you say start it, we basically bring it, find a appropriate blade that has availability to run that machine based on the size of the machine. We then bring it down, we turn it on, we consume resources on that. That's when the ticker starts counting for the bills. Once you say stop within the VM, it stays there. It hasn't been deprovisioned yet. Once you say stop within the portal, we say, okay, we'll shut this down properly within the OS, regardless of what the OS is. And then once it's properly shut down, the disks have all acquiesced and they're all good, we then simply put that machine back in storage, if you will. So you're only paying for storage, but only if you stop it from within the console or through programmatic API call or through PowerShell or whatever it is you happen to do. The question is, if we stop the machine and it stays inside my storage account, what's the retention for that particular box? For how long? As long as you want to pay us to have it stored there as bits. So as long as you keep on paying your bill, you're good to go. Have you ever been to one of my sessions before, sir? You have, so you know that you get to have one of my Canadian maple syrups down here with your name on it. You can come get it later. So that's incentive for the rest of you. I've got 2 left for good possible questions. Next up is ARM templates, or Azure Resource Manager templates. I alluded to this already, the concept of going through with a defined file that allows you to define your infrastructure. You then have inside that file references to the operating system, the network, the subnets, the infrastructure required to run this, the operating system on the different VMs, the number of disks, the number of attaches to those disks, all that sort of stuff. That gets fed in through the various tools into the Service Management API and Resource Manager. It then goes in and talks to the different resource providers that are involved, that are being called upon inside that template, and then spits out the machine. Part of that spitting out process of having that machine be defined inside that ARM template is it has the ability to call on extensions. Those extensions could be a run this PowerShell script after you've done this, and that will do my Active Directory configuration. Run this Chef extension that will go in with a bunch of variables and go and provision that box to go and talk to a Chef server, enterprise server, to get more configuration details. Or could be Puppet, could be whatever you want, doesn't matter what it happens to be. That's how the basic Azure Resource Manager concept works. So this file goes through and basically declares what is required for your project, not just an individual machine, goes through and allows you to have simplified deployment because you've now tested it, it works, you now can go off and deploy. It allows you to go through and make changes to that on the fly, check that in the source control, bring it back again. The important part about templates is once you've done your testing, you've done your design, done your build, you now have this ARM template, you can now save that, and you know that whenever that machine or that project gets deployed using the ARM template, it's not going to be different than the last time you did that single deploy, because it's a file as opposed to human intervention of doing GUI clicks between the different services and resources that are out there. So from a support perspective, from a design perspective, Azure Resource Manager templates are very attractive. It is definitely a learning curve to get used to how templates are designed and how they work. And I've got a resource manager template here, very quick and simple. As an example, this is a resource manager template, which I found on the, where is it? Here it is. Yeah, this is a resource manager template that is available on the Azure website that shows you how to go off and very quickly deploy 20 machines that are all identical. In this case, they happen to be running Ubuntu Linux. That's up there. Go ahead and say deploy to Azure, just as a quick demo. This template is going to go through. It has a bunch of different sections that are defined, one of which is asking me for some parameters to make them personalized. So as you can see, it spins up and it's ready to go. I'm going to fill in my admin username. I'm going to put in my password, super secure. I'm going to say, let's make 20 instances of this operating system, put them inside West US. I'm going to make them a D1 size. I'm going to be using Ubuntu server and hit OK. I'm going to say, go ahead and create a new resource group. I'm just going to call it Quick Scale. It's going to be in West US, because that's where I want it to be. That's good. I'm going to say create. Oops. Come on. OK, you know what? I'm just going to go and let's put him inside perf demo, because I know he already exists right now. That's good. What did I miss? Oh, review the terms, of course. When you're going through, the last step is you have to go through and review the licensing terms for the software that might be inside this template. In this case, I just read that. I'm going to hit purchase and then hit create. And off it goes and does that deploy. When I go and take a look at that guy running off in the background in parallel, I put him inside AU perf demo. You should now start to see, ever so slowly, a bunch of resources now starting to come up. There we go. You can see that in this case, in parallel, all these public IP addresses are now being requested in the background. Hit the refresh button. NICs are going to be created as well. Subnets are going to be created. VMs will be created. On the availability set, I don't have any machines in there as of yet, but the blank availability set's been created. So basically, I'm doing a bunch of different tasks in parallel to quickly deploy 20 cores of a D1 inside of my system, inside of my subscription, quite quickly. Now, this is purely a demo. I can't do anything once they've been deployed because I haven't configured them to actually do anything other than simply deploy 20 different VMs across my subscription. That's it. With a ARM template, I mentioned the parallel capabilities of being able to go off and deploy from a scale perspective, the ability to go off and have fault domains. I'll talk about those in just a little bit inside of a single availability set. And then also, obviously, I can go through and do custom scripts and also extensions to configure those VMs as well. That little URL reference down there is a very simple, potentially learning tool of a Azure Resource Manager template that is known as the Virtual Machines Application Framework that will show you how to build a loop inside of the ARM template that simply spins up 20 instances, because I had the number in there, 20 instances of those VMs that's in there. So a JSON file is literally a text file that goes through and declares and defines a bunch of different things. Inside of it, it declares and tells you what schema version it's going to be using for what it's able to talk to, the different parameters that can be asked, the different variables that can be plugged into it, and also resources that get called on, and then finally the outputs that are there. So in this case, from a parameters perspective, you saw me type in the administrator account name, the administrator account password, potentially what the storage account was going to be, but in this case it took a default value, didn't really care as long as it worked. The variables, which were hard-coded, it was going to go in and talk to a different location. It has different subnet and IP address ranges that can be used. All these are declared and defined. I'm mentioning this because when we start talking about performance, again, if you do the work and analyze your existing application you want to go and deploy, or the one you're now building, if you define the infrastructure inside of an ARM template as you're building it and you go through different iterations, you can now start to do accurate performance tests on that different infrastructure. and you know that you're going to be doing the performance test across the same way that the devs are going through and doing the different iterations of things. As you make a tweak or a change for performance, you have to update that ARM template or update the configuration scripts per se to make sure they're also now up to date and ready to go as well. This gives you that consistency and removes that human fudge factor for there being any kind of problems. There's an example of the different resources that get called. In this case, there's a storage account being created. There is a public IP address being requested, and that sort of stuff. And then finally, examples of what a default value could look like. If I don't specify something specifically, it can go through and default to using, in this case, 2012 R2 data center for the operating system. So, availability sets is the next section I want to talk about. I'll be coming down into the big area of performance, which is next, talking about drives. But availability sets comes in mainly because when we provision something inside our own network, we're responsible for ensuring that the lower level hypervisor, the disks, the network, and all the rest of the different factors for performance are all set up and available for those applications to run. If you have an application that needs to be highly available, you then have to use the software to make sure that that particular application is highly available. Maybe it's clustering, maybe it's replication. You choose whatever happens to be. But you also have to do that at the lower level of the infrastructure to make sure that your disks are protected. You've got data that's being striped or mirrored across different data disks, that sort of stuff, on your own fabric layer. In the cloud environments, you don't have control of that level of stuff. We have to have control of that as Microsoft, as your cloud provider. So one of the things that we say is that, well, if you want to have an SLA with us, you have to ensure that when you deploy something, it goes inside of an availability set with a minimum of 2 different systems inside of it, and then we'll give you an SLA. Those availability sets literally are a matter of, in this case, here's an example of a SQL environment, a virtual machine running with a primary and a secondary SQL server. We'll give you a 99.95 availability on that particular system, provided it's running. What that means is the lower level fabric underneath that is not going to cause you problems. It's going to make both of those guys to go down. As long as if one of them has to go down for maintenance, as an example, because the lower level fabric underneath where that guy is running has to go down for maintenance, the other guy is still going to be able to function and provide your services to your application that's there. This works regardless if it's Windows or if it's Linux. If I kind of break that down into the physicals, here's a server rack. Inside of a server rack, I've got blades, or I've got pizza boxes in this particular archaic description. And on there is running my fabric and my different levels of hypervisor, let's say, from a compute perspective. Inside that rack, I've got power that's on that rack that could fail. I've got switches on that rack that could fail. So when I'm saying put them inside of an availability set, the fabric in the back end, what that guy's going to go ahead and do is basically say, well, these are multiple thousands of racks across my data center. Each one of those is now going to be available to receive one or the other of your availability set, in which case now when I go off and I deploy, on the fabric side of things, we're going to ensure that those 2 machines are across different fault zones so that if one rack switch goes down or if one rack power goes down, only one of those guys is going to be knocked out. The other guy is still going to be running and providing services for your application. Therefore, your availability is still functioning. So when one guy goes down, that other guy eventually gets reprovisioned on another available blade, comes back up again, and then the logic of the application is going to go through and synchronize and make sure everything's all happy and continues to work. So availability sets are very important to understand. A lot of times when people are designing applications or want to move stuff from on-premises up into the cloud, they don't think about availability sets and how they work. And they simply have a single instance which doesn't have an SLA. So guidance on this. VMs need to be inside an availability set for that SLA. That availability set has to be inside the same resource group when you're designing how things are going to be laid out. Your availability set now has, with the new Azure Resource Manager, 5 update domains and 3 fault domains. What that means is if you've got 10 systems inside of your availability set, we're going to sprinkle them across so that they're equally across all those different update domains. And they're also across all those different fault domains as well, as best as they can. So you're going to get the best number of machines up and running in case something happens to go down. Your update domain basically will cover you for host maintenance, the fabric. You have to do a patch or something like that, or in case there's a fabric power switch that fails inside of there. The fault domain is from component failures inside the rack unit that's up there. You can have up to 100 VMs inside an availability set. We'll handle the logic of sprinkling them across the different environments, and we'll also make sure that things are all happy and working with updates. One thing that I will mention is the very bottom of that slide, which is important, as I just quickly see how these guys are going from a deployment perspective, is the fact that, yes, there we go, is the fact that if you create a machine and you put it into an availability set, but you only have one machine inside of that availability set, you're not going to be notified of something going down. So we'll notify you when we have to do maintenance of the lower level fabrics to say this is your maintenance window. It's going to be hitting your data center. And so long as your applications are designed to work within availability sets, you should be fine. Now, I ran that ARM template to show you specifically those 20 machines. They are currently spread across 3 different fault domains, 5 different update domains, and it is 20 machines in total that are now running inside this environment. If I had additional Chef extensions that I plugged in with configuration, they would be receiving the configurations from the centralized Chef server. They would have turned into web servers with different things on top of it and sort of stuff, and they would have been configured correctly. So in this case, I've got a good level of protection and scale working inside of this particular fabric that I just created. Now, a good chunk of this topic talks about drives. And the reason why it talks about drives is because this is where I personally have seen a lot of people end up kind of hitting the wall when it comes to performance. And this is where people will also go through and simply say, throw more resources at it, bump it up to a D14, bump it up to a G, to be able to just get the quick fix. But essentially, doing that hard conversation around IOPS, remember the picture of the cat at the very beginning? That's kind of the expression you're probably going to get the first time you try to have this conversation. Have that IOPS discussion with what's possible, because it comes down to different types of drives and how they work. So when you go off and you provision a machine, you create a storage account. That storage account may be already in use, may be empty. You're then going to go and plop a blob in there. That blob is going to be your operating system disk. The operating system disk is going to have compute associated with it. It's going to spin up and going to start to work. What happens to an operating system when it boots? It starts reading and writing to that disk about a whole bunch of different sort of stuff. That creates IOPS. What happens when it's done booting and just sitting there waiting? It's going to have less IOPS, less used. What type of data, what type of stuff is going to cause more IOPS? Your application is going to cause more IOPS. Maybe it's going to be a database. Maybe it's going to be some kind of caching or whatever it happens to be. That's when this comes into play. So in this case, I've gone and I've dropped the VHD down onto a particular blade. It's now running off of that blade on the fabric. I now have my C drive, which is running. I've got a disk cache mechanism in place, and then I'm going to be talking to that individual blob for that OS disk. I have something called a temporary disk, or a D drive. That D drive, do I have this guy right here? That D drive is very important to know because performance-wise, that D drive is going to give you more or less performance based on what version of machine is you deploy. I want to show you this explicitly because some people forget about this. They say, oh man, I'm just going to put my OS down on my OS disk, and then I'm just going to go ahead and I'm going to write stuff and put stuff onto my D drive, even though that we explicitly tell you, including a text file, that says, this is a temporary disk. Do not store stuff on this. It will be subject to loss at any point in time with no way to be able to get data back from it. And I think we also have it, I think that's Chinese as well, at the bottom of the screen. Do not ignore this warning. The only reason why you should be using your data disk, the D drive as a data disk, is if it's absolutely temporary. You don't care if it's there. If it disappears because the machine is restarted, you're not going to be impacted by that. If you can write your applications, or if you have a routine that is able to handle that, great, you could possibly use it. But nothing that's on that disk will be there if that machine gets reprovisioned. That's your D drive. So that temporary disk comes into play from a performance perspective, and you can design some stuff for performance. The A series, the D drive, is going to be on spinning Rust, spinning disks. You're going to get so much performance off of those disks, and that's it. The D, the DS, the G, the GS, their D drives are SSDs. So those blades that the CPU computes running off of have SSDs that are on there. And that temporary disk gets used for caching to make sure that we get better performance off of it. So from a temporary drive perspective, you never place critical stuff on there. You can use it for SQL environments, for SQL TempDB if you wanted to, because it is relatively fast for the D series. They got instructions in a blog post to talk about it. It's still valid. If you need to actually have a folder structure to get created on that drive for your SQL TempDBs to work, you can have a scheduled task on boot up of that machine to always create the proper folder structure, and that way, if the machine gets deprovisioned and reprovisioned on new hardware, those folder structures will be there. Test your scheduled tasks to make sure that they work. All you have to do is do a resize operation that'll force it to be deployed to a new box, be deprovisioned, and then reprovisioned, and then that'll test to make sure things work. Now, digging through one of the best documents out there for performance. Again, there in the URL, specifically this is a blog post from 2014. It's still valid for D series. You can see that the D series for the number of cores, 1, 2, 3, 4, 8, and 16, have more or less cores. They also have larger temp disks on the C drive, and also they have different amounts of maximum IOPS specifically for that temp disk. So if you find that your database needs to have a very fast temp disk, and you've done your IOPS analysis, and you find that it needs to have about 10,000 IOPS, you know you can't deploy that to a D2 or to a D11, because it only has 6,000 IOPS before it starts to max out on the temp local drive that's there. Therefore, you have to go with a 4-core system with a D3, a D4, or a 12, 13, or a 14. This is mind-numbing numbers, but it's good to know that they're there, they're published, and if you take these into account, you will go at least a couple steps further than having that cocktail party napkin discussion about how to do performance design. Now, this is where it gets to be interesting for the next level of performance is not just the C drive and the D drive, but also now all of your data drives. Your data drives are persistent. They're the drives that you attach up. They're durable. They follow the machine around. They're inside of blob storage. They move with the machine as the machine gets repositioned inside of our fabric for any given reason, and that's where you're basically going to be storing your data. This is where the IOPS conversation comes into big time. The more drives you associate inside of a striped environment, the more performance of IOPS you're going to be able to get, because each drive has a limit with how much it can go through and pump through. When we have a drive write take place, we actually will go ahead and have 3 copies of that disk available inside of our network infrastructure inside the data center region, and we make 3 copies of it. And it's now available and populated. You're only ever going to be using one of those copies when the machine's there, but in case that particular storage that drive is now associated with happens to blow up, we have the other copies available, and the machine is able to go off and continue to function. Now, we have 500 IOPS per disk that's available as available maximum bandwidth. A premium disk, which I'll talk about in just a little bit, actually has upwards of 5,000 IOPS per disk. As soon as we go away from the premium and back to the standard, we now, if you wanted to, can also go through and give a better level of resiliency by doing a regional replication between 2 different regions. And we give you suggested pairing regions that you can use between those different systems if you wanted to. This does not apply to premium disks. So from a data perspective, a persistent and data disk perspective, first off, get more IOPS for your environments because you've done the research for what your apps need to have. You're going to basically be going in and sizing the machine for how many disks it can maximum have attached. If you're talking spinning Rust, you're going to get 500 IOPS per disk. Times the number of disks, 4 disks, 500 IOPS, that's 2,000 IOPS, theoretical maximum you're going to get off of that particular system. You would take those 4 disks inside the operating system, be it Linux, be it Windows, and you would use the operating system's mechanism for going in and ganging those disks together. They appear as physicals. RAID across them. And this is another debate that I have. Because we give you the 3 levels of redundancy down at the lower level fabric, you don't need to worry about putting in RAID, mirroring, or RAID parity, or any other versions of it. Because those disks will always be available to you. You can't have a disk failure because we've got 2 other copies inside that environment. And so, for speed perspective, you're going to go through and simply stripe the data across these guys. This makes the hair on the back of my neck stand up, because I'm an infrastructure guy used to having disks that fail. This is a cloud provider we're talking about now. We're the ones responsible for ensuring the storage is there, so the disks aren't going to go and fail on us. Spinning Rust, I mentioned 500. SSD backs premium storage are 5,000 IOPS. Now, the one thing about premium storage is when you provision a premium storage disk, you're going to have a choice of a P1, a P2, and a P3. The difference is size and associated maximum IOPS. A P1 is going to have 500 IOPS, and it's going to be the smallest size of 128 gigs. It's going to basically act the exact same way as if it was a spinning Rust. A P2 is going to be 512, and it's going to have 2300. And a P3 is going to be 5,000, and it's going to be 1,023 gigabytes, or 1 terabyte in size. Gang those all together for the size and number of disks that you happen to have, for the size of VM, that gets you your maximum IOPS. So when I was in there earlier inside the portal, as I close these windows off and bring this guy back again, and a switch, I have my simple disk attached system. Inside of my disk attached system, I already know under all settings that my size has been set up for this guy, if I remember correctly, is a DS2. DS2 is a maximum of 6,400 maximum IOPS, because you can have 4 disks that are on there. The more disks you have, the more possible IOPS that you happen to have. When I go in and I take a look at the different types of disks that I want to create, I simply would go in. I already have 3 created on this individual guy right here. I simply go in and say attach new disk. It's a premium. It's 1,300, 1,023 gigabytes, or 1 terabyte in size. My IOPS limit is 5,000 for that disk, and I've got a throughput of 200 megabytes per second. You can, in theory, actually come up to a point where you don't have enough throughput of the network between the compute and the disk in the back end. So that's why the higher P3s you go, the more IOPS limits you get. So I'm going to choose go ahead and do this. If I geared them down, you'll see that the IOPS go down. If I go to the smallest level, it goes down as well. I'm going to keep them nice and big. I'm going to call this disk attached number 4. Hit OK. He basically is now going in, finding the resources available on that SSD back storage, creating me a new VHD file that is 1 terabyte in size, and now associating it back to my machine and making it available. And here we go. I think, oh, did you get it? Still, they're updating. Perfect. It's now done for 4 disks that are now attached on there. I have this guy up and running as disk attach. If I go in and run Disk Mangler, come on. Oh, look, I've lost my connection. Oh. Let's connect back up again, please. I'm even hardwired in because it's the end of the day. I guess the bits are running pretty slow today. Yes?
Why is it that the VMs do this? We see this all the time. But when we attach a disk to a running VM, we lose connectivity.
Can you repeat that again? There's a mic right there. It's hard to hear you over the fans.
So we actually see this all the time, that when we go and attach another disk to a running VM, it will actually lose this RDP connectivity momentarily.
Yeah.
Do you know why that is?
I actually do not know why that is. The machine doesn't stop running. Basically, you've got a network attached that's happening to that individual disk up to that VM, and he comes in. Programmatically, you normally would be attaching these disks once and they're in and you're good. You're not going to be doing this on the fly, but it is possible. If I go in here and try that again with my Windows key X for Disk Manager, you can now see under Disk Management, there's now 1, 2, 3, 4 disks that are available that aren't currently in use. And they're all approximately 1 terabyte in size, and they're all attached. Now, I'm going to go through and just, you've seen this potentially before, inside of Storage or Server Manager for Disk Attach under Storage Pools. I currently only have empty primordial disks available. New storage pool very quickly. Go through and call this data pool. Use all my disks. Bring it in, create. Create a virtual disk afterwards. Thank you very much. Virtual disk comes up. I'm going to be choosing simple, much to the chagrin of the hairs in the back of my neck. I'm going to say fixed and use the maximum size because I'm paying for it. And then hit create. And then lastly, I'm going to create a volume, and the volume makes it available to the operating system to be able to map it as a drive and do it. I wanted to show you this last little bit right here because you may not be aware, but some people I know will go through and turn this on. I don't know why. Maybe it's because they just have nostalgia back to the olden days. This will actually kill the performance of the file system on this individual disk. Don't ever turn that on unless for some reason you have some application that needs to have that on. Please do not turn that on. Go ahead and create that, make it available, comes up, formats the volume. F drive will now become available, and that's going to have 4 5,000 IOPS capable disks that can now, in a Stripe environment, could now support potentially up to 2,000 IOPS on that one particular drive. Hit close and done. Now I went ahead and I have, let's see if these guys are up and running, an SSD-backed VM that's here that I've been running for a little bit of time. And this is one that basically has the Iometer tool installed on it. And he has, how many disks on this guy again? Let me see, I think he's got 8. Yes, he's got 8 disks. And I'm getting approximately 11,000 IOPS on this guy from an SSD-backed machine for the way it's running. This is a very simple test. I'm just doing reads. I'm not doing read-writes on this particular environment to be able to go off and do a very quick check to see how much performance I have off of him. Now, I have another machine, but it hasn't finished prepping the disks as of yet for Iometer to work, that actually has 32 disks that are attached to be able to go off and get even more IOPS on that individual guy, even though he is running on standard standard spinning as opposed to SSD. The idea is that even with a standard spinning Rust disk, you can cram enough disks attached to the operating system to get a lot of IOPS. You can get the same performance for a much smaller premium disk set up with a DS system to get those IOPS, but you're paying for the premium, so there's kind of a trade-off. So that gentleman asked me, how much does it cost to run the machine when it's turned off? You're only paying for the disk bytes at rest, and that's it. On a premium SSD setup, a P1, a P2, and a P3, or a P10, P20, P30 to be exact, you're actually paying for the entire disk because it's such a premium. So it is more expensive to have those particular systems configured. And I have to remember at the end of this demo to turn off this system because I'm paying for 8 terabytes of premium storage right now, even though all I'm doing is a very simple read I/O test on this environment. So this comes into play from an architectural perspective because not only do you have to worry about individual VMs having IOPS to satisfy their environment, those VMs are talking to VHDs that are backed by a storage account. There's a 20,000 IOP limit on that storage account for spinning Rust. So you can only have, maybe if I work out the math, approximately 40 or so VHD files running off of that particular storage account before I max out the IOPS on that storage account if it's spinning Rust. So if I have a very large solution or project that I'm running with multiple data disks, I'm going to have to spread those disks from all the different VMs across multiple storage accounts to make sure that I don't hit this bottleneck of 20,000 IOPS for spinning disks. I don't have that same limit on a premium SSD-backed system, but I do have a size limit, a 32 terabyte size, or 32 P3 disks or P30 disks that are there on my premium storage account. And if you remember, the G-Series machine can have up to 34 disks attached to it. So I'd have to split those across multiple premium storage accounts that are out there too. That's a quick background check that some people end up running into with a problem for designing their environment for more resiliency. Yes, sir, right there. Is there latency for the reads and writes on a IOPS that is a spinning disk versus an IOPS that are on an SSD? Absolutely, there is going to be faster and slower millisecond writes to the different disks. We try to offset as much of that as we can with caching where possible. So on a D-series machine that has a temporary SSD D drive, we're actually going to have a caching layer that's on there so that we run at the fabric level. So if you're making requests to the particular read access, let's say, on a large data volume that's there. If you've asked for that information before, it's still going to potentially be on the local SSD cache, in which case it's going to actually transparent to you, pull it off the local SSD to get you better performance, not charged for the premium because it's part of the regular caching. But then if it's not in a local cache, it goes through and down across the network to where the VHD file resides and then come back across to make it look like it's a local read instead. So there is performance acceleration that we tweak and tune, and we do our best to make sure we give you the best experience possible. I think that's worth a good maple syrup for you there too, sir. Don't forget that on your way out. So scale units, before I want to wrap this one up just a little bit, scale units is that thing that basically governs when you create a machine and you provision it to an individual environment inside of Azure, inside of a data center. You're going to end up with, if you choose, let's say, a D1, let's say, and then now the dev test is working great, it's all fine, you now want to go off and now up this into more of a production environment, do some actual pilots and some testing. You can, again, simply go through, change that ARM template, or go into the portal and change the size of that VM. You're only going to have certain ones you can scale up and scale down to because of what's known as a scale unit inside of your environment. So a compute unit that's capable of supporting a defined range of different VM sizes. Every VM deployment is bound to the scale unit that it was deployed to at first until you deprovision it. So simply by going through a resize, you're going to be restarting that environment, basically shutting the box down. It's going to restart and come back up again on that new environment. Scale units and examples, think of this also as possibly the old way that we deployed our hardware. An A0 through A4 could potentially be on a scale unit of the very oldest one of a scale unit number 1. Scale unit 2 is A0 to A7. Scale 3 is only that new high data capability for HPC that is RDMA enabled. Scale unit 4 is A0 through A7 and the D series as well. So this is a more modern data center. So it's kind of cool if you actually go and provision a workload inside of the Sydney data center here in Australia for East Australia, and you go ahead and you provision it as an A4, let's say. You'll have the picking drop-down box capability of going either on the A's or even moving over to the D's potentially. Because that scale unit was probably the one that was deployed as the bulk of what happens to be inside of the East Australia data center. Same thing applies for the West Australia data center. If I deploy this inside of West US, one of our first data centers, I might end up stuck on a unit number 2, and I can't even see the D series. In which case, I'm a little sad, and I got to go off and reprovision that box and redeploy them back down again. So scale units come into play at different points in time when you're doing the resize. I've already shown you the resize capabilities of looking at that machine, going in as it's running, and then changing the scale unit. It's going to deprovision that box, reprovision them on the new scale unit, and then bring them up again for being able to go off and deploy. So I've got about 6 minutes left to take a couple of questions. I've also got some other stuff to share with regard to some closing thoughts on how this works. Ideally, what I was trying to get out of this particular session is there's a lot of documentation you have to go through and read, very fine points, that is constantly evolving and changing. My first recommendation to you is, if it's a blog post, even if it's a Microsoft blog post about performance limits that exist with network bandwidth, let's say, or disk IOPS, or hardware configurations, if it's a blog post, check to see when it was updated and written and last time it was updated and rewritten, because it's constantly evolving and changing. Like the DV2s. I had no idea the DV2s were even available yet until I went in and tried to provision a new machine and saw that I could select a DV2 inside of the data center that I happened to be in. That was kind of cool. So that thing kind of changes very quickly. Likewise as well, if it is an Azure documentation, we do our absolute best that as a new thing comes out in preview or in final, we update the Azure documentation off of the Azure.com websites. The Azure.com website is actually backed from a documentation perspective on a community updatable GitHub document repo. So that if things change, if things are identified as being incorrect or need to be fixed, we actually will take pull requests from the outside of people that have done the testing. It gets validated by an authority on that particular area, and if it's deemed to be accurate and correct, we'll actually accept that into the documentation updates, and we have updated documentation. The biggest thing I'll definitely tell you is don't just fall into the same old trap of just asking for more resources. Spend the time to do the analysis and the hard work of understanding where bottlenecks could be. The first place I check is if it's infrastructure, size of machine, number of attached disks to get the maximum number of IOPS. Once I know that kind of formula for what's been done, did they place the data and the applications on those particular machines in such a way that's taken advantage of those IOPS? Do some testing with Iometer, as an example, to see with the profile of data for the typical types of reads and writes, to see if that performance will change if I swap that out from a 4-disk configuration to an 8-disk configuration to a 16-disk configuration to get more or less IOPS. Don't just jump to saying that you have to go and also jump to premium storage. Premium storage you pay a premium for because it's not just the amount of bits written to the disk, it's the amount of the overall size of that disk that you end up paying for. So it definitely becomes to be more expensive. Can your workloads be broken down across multiple machines? This requires normally some kind of an application update or application rewrite, or maybe it's already built in, they just haven't tried this out yet. Obviously in a cloud environment, if it's a net new application, don't try to design it the same way you would on premises. Start looking at things like Service Fabric, little microservices. Start taking a look at containers to be able to go through and to spread the load and scale up and scale down very, very quickly. And also to make it so you can turn things on and turn things off very, very quickly in a reactive and even proactive manner to go off and to get better performance and to save you resources and to save you time. This multiple machine piece definitely comes into play as well when you're doing your initial design for availability with availability sets. Are you hitting any internal governors within your subscription with the number of storage accounts, the number of IOPS per storage account, the size of that storage account, the number of disks that are very heavy versus not so heavy? You can fit 60 or 70 OS disks inside of a spinning Rust storage account because it's only really the boot up time that's going to be affected with those IOPS. After it's settled down, maybe it's going to fit within that 20,000 IOPS that happen to be there. If it's a high data frequency, lots of IOs that are going through there, you're definitely going to want to stripe across multiple or spread the load across multiple storage accounts that are out there. Same thing with resource groups as well. And finally, are you designing for the IOPS against that storage account? It's probably the biggest thing that comes across for performance reasons. You don't see that much of a network issue. There are network limits and governors in place for the amount of inbound and outbound traffic. That's why we have load balancers. That's why you can put multiple machines behind a load balancer. We have traffic managers as well at the outside layer. I'm not going to be talking about these areas today. I'm focused mostly on the infrastructure and the IOPS. But obviously, using those different tools allows you to spread the load across multiple geographical regions, multiple data centers, multiple machines to get the better flow before you start to hit that IOPS level of the individual disk. And with that, there's one last point that I'll make is use your knowledge and your common sense of what you've been doing and working with the IT industry, even if it's only in the on-premises world. If you just take the time and step back and look at how you can characterize the workloads running in these different environments, you'll find that there's definitely some workloads that make sense to have up inside of Azure. There's some that might make more sense to have on premises until the project can be updated to take advantage of stuff inside the Azure world, and understand that we can work inside of a hybrid environment as well. I was with one customer doing a discussion with them, and they determined that, you know what? This one piece of this big massive workflow, that makes total sense for us to go off and do this dynamic, spin it up inside of Azure, do the processing and shut it back down again when it's done. But the 17 petabytes worth of data that we have, we're going to keep that on premises for right now because it's just not going to be cost effective for us to move it up to the Azure world, even though a Ute load of USB disks could have been used to move it into our data centers if you wanted to. And with that, I'm going to say I've got about 40 or 5 seconds left or so. I will be able to come down and take some questions here at the front. I do have a wide variety of stickers, as I promised at the beginning. If you're interested in having one of those awesome My Other Computers in Azure Data Center sticker, come on down. But thank you very much. If you do want to get a hold of me, I will be at the party tonight. Get to me early because I do understand there will be liquor there. But on top of that, you can also find me anytime. I'm here today, I'm here tomorrow, and I'm out there tonight. Just look for the hat that I'm there. Please, if you could, you've heard this from every single session you've heard today. The evaluations are extremely important. If this was something you found interesting and useful, let us know inside the comments, not just in the numbers, 5 is good, 1 is bad. I'd love to hear, was this good? Did I miss something? Should I have gone into more depth in different areas? Or did I miss the boat completely? Let me know what I can do to make this session better. It's about the 5th or 6th time I've run this one, and I always like to update it. With that, I'm 20 seconds over, but I started a little bit late. Thank you for your time. I appreciate it. Lots more resources that are up there. And with that, good evening. Don't forget your badges to get into the party.